All right, let's take a look at the general form of linear and exponential functions and see how they compare with each other. So we know that the general form of a linear function is y equals mx plus b, right? The y-intercept is b, and the slope is m. So y equals mx plus b, but I guess I have it written as b equals mx. That's okay, because addition is commutative, and I can add in any order. But you can see that if you remember what multiplication means, it means you're adding something over and over again. If you remember back in grade school when you learned to multiply, you probably first learned to skip count, right? So if you're skip counting by 3, 6, 9, 12, 15, right? Those are the multiples of 3, right? So 15 is 5 times 3 because it's the fifth one you get to when you skip count. So you're just adding 3 and adding 3 and adding 3. So you add 3 over and over 5 times, you get 5 times 3. So now this is if x is a positive integer. All right, if x is a positive integer, then essentially this formula y equals mx plus b, or y equals b plus mx, is b plus m plus m plus m plus m x times, right? Because that's what m times x means, is that you're adding m x times. Okay, so that's one way to look at the formula, and that helps you understand why the difference between consecutive terms is, as long as you have a constant delta x, that the difference between consecutive y values is going to be constant. So in the formula, b tells us the y-intercept. It's the value when x equals 0, right? So if x is equal to 0, m times 0 is 0. So y is b when x is 0. And that's the y-intercept. The value of m tells us the rate of change, right? It's the slope of the line. For an exponential function, right, it's the general form is this, a times b to the x, right? So we're taking a and multiplying it times b, and then b again, and b again, and b again, x times. So that's what an exponent means. You're taking a number and multiplying it times itself over and over again, right? So if x again is a positive integer, so x is a positive integer, then this formula y equals a times b to the x can be written as a times b times b times b, right, where we're multiplying by b x times. All right, the value of a in the formula tells you the y-intercept, right? Because when the y-intercept is when x is equal to 0. If you put 0 into the formula, b to the 0 is 1, right? No matter what b is, anything to the 0 power is 1, and so you just get y equals a. So a is the y-intercept. The value of b tells you the growth factor. Okay, it's the multiplier. That's why it's a factor, right? It's the multiplier. You're multiplying by b over and over again. So it's the growth factor, and the growth rate is r, which is b minus 1. Right, because we know that b is equal to 1 plus r. Okay. All right. So let's take a look at this next example where we're going to look at some linear and exponential growth or decay. All right. So here we want to find the formula for the price of a gallon of gasoline if the price is $3.50 today at t equals 0. And we have these different scenarios. It's increasing by 10 cents per day, right? So I'm going to call this a function P of t, P for price, right? So what do we have? We have $3.50. That's what we're starting out with, right? And then we're just adding 10 cents for the first day, another 10 cents for the second day, and 10 cents. We're just adding. So you could think of it as, 10 cents plus 10 cents. Oops. Let me write that as 10 cents. I rated this, it's 0.1 because it's, obviously it's $0.1 is 10 cents. All right, and so on, right? So what we have is $3.50 plus 0.10 times t. And that will give us the price at any given day, t, from today, where t is the number of days from today. All right. Now, what if it's decreasing, right? What if it's decreasing by 5 cents a day, right? So now the price is going down. The price is today is $3.50, and we're subtracting 5 cents, $0.05, right? And we're subtracting it again, 0.05 minus 0.05, and so on, for however many days out we want to go, right? So the short way to write that is to say that we're going to take $3.50 and subtract 5 cents t times. All right, that will give us the value, or the price of the gas t days from today. All right, so you can see this 10 cents, this is our rate of change, right? This is the rate of change. This is rate of change, or it's the slope of the function, right? Here our rate of change is negative because the price of gas is going down. Rate of change. Okay, so the rate of change is the slope of a linear function. So these are linear functions. All right, so now these next two parts, we have the gases again, 350 today, but it's increasing by 2% per day, right? So we can think of the price at T as being, okay, it's 350 now. So tomorrow it's going to be 350 times 1.02, right? That's how we can add 2%. That's our growth factor. We're just adding the growth rate plus 1, right? So it's 100% plus 2%, right? So I'll put it in parentheses. Might be easier to read that way. All right, and then that's if that's after 1 day. If we want it after 2 days, it's going to grow by 2% again, and then 2% again, and so on each day. And so we end up with 350 times 1.02 to the t. All right, so we have an exponential function. That's supposed to be a decimal point. 350. All right, and now last one here is now the price of gas is decreasing by 1% per day, right? So it's decreasing by 1%, meaning that the price of gas is 99% of what it was the day before. So we're starting out at 350, okay? And so this is our growth rate. This is our growth rate, but it's decreasing. So like up here, our growth rate was 0.02. Here, our growth rate is decreasing, so it's a negative 0.01. Okay, it's decreasing by 1% each day. So our growth factor is 99% or 0.99. All right, so the first day, the price is 99% of what it was the day before. And then the second day, we would take that price and multiply by another 0.99, and so on. So the price of gas, if it's decreasing by 1% each day, is just going to be $3.50 times 0.99 to the t. So now one thing to be careful of is that because our percent decreases or increases were given in days, then this t is in days. Well, for all of these, actually, right? All of these, t is in days. Okay. All right. Well, I will meet you in the next example.